Assalamu alaikum. Today we are going to be learning about developing, debugging, and demoing machine learning applications fast by Abubakar Abid. Abubakar will share some tips based on his years of experience developing machine learning applications for how to quickly develop, debug, and demo machine learning applications for hackathons. Assumes some familiarity with basic machine learning concepts. So a part of this, there's like it's kind of, I would say it's a little bit more intermediate. Abubakar is the CEO and one of the founders of Gradio, which builds visualization and debugging tools for machine learning developers. Before that, he was a PhD student in machine learning at Stanford, did his undergrad at MIT. On the side, he loves to read books. Of all genres and participating in Islamic calligraphy. He is also one of the early engineers at Tartil.
All right. Jazakallah khair, bro. Thank you so much for that introduction. I'm honestly just really happy to be here and really gracious and grateful that you invited me to join Hack. So what I'm going to do is I'm actually now going to switch over to my computer. So there might be a momentary transition. All right. Assalamu alaikum, everybody. Can you still hear me?
We can, yes.
Okay, fantastic. Okay, my name might be, let me go ahead and start the video. Okay, here we go. Yeah, so as Shams said, I'm going to be talking about machine learning applications, and specifically in the context of hackathons, because I've worked on Muslim projects in hackathons before. I've attended a lot of other hackathons, and one of the key constraints that you often have in hackathons is time. You have to move really fast, and you have to build these machine learning applications fast, and deploy them fast, and demo them fast. In Hacks, of course, we do have more time than is maybe typical for a hackathon, but still, you know, we're all always constrained by time. So hopefully some of the tips that I'll share today will help you just kind of prototype machine learning applications and build machine learning applications faster. So I put together a few slides, and so I'll just go through them. So as Shams said, I'm going to be talking about developing, debugging, and deploying machine learning faster. So as part of one of the things, well, okay, let me just give a little bit of background about myself. So as Shams said, I helped start Tartil. So Tartil is an organization, an app that maybe some of you have actually used. It's basically AI-assisted Quran recitation. So you read to the app, it figures out what you're reciting, and if there are mistakes or anything like that, it can detect that. It can at least follow along with what you're reciting, and so as a result, it can be useful if you're trying to perfect or improve your memorization of the Quran. I started this about 1.5 years ago, or almost 2 years at this point. Besides that, in my day-to-day life, I'm actually I've been doing my PhD at Stanford in machine learning for a few years now. I do all sorts of different things, like look at machine learning models and try to understand what they're looking at in pictures. For example, when they try to classify pictures. I do a lot of medical imaging work as well, which I'll talk about later briefly. Most recently, I actually took a break for my PhD. I took a leave to start a company called Gradio. And what Gradio is all about, I'm going to tell you a lot more about it later, but it's really designed to make UIs, building UIs and GUIs and user interfaces around machine learning models much faster. Okay, all that being said, what am I going to talk about today? What I'm going to be talking about is actually I'm going to talk about, when people talk about machine learning, there's various different steps of the process, right? This is a very common figure. Maybe you guys have seen it before, but people say that there's like at least 5 steps to data science, and it's like a circle, and you can take a look at them here. I won't necessarily describe them, but what I'm going to be talking about in this short talk, inshallah, is 2 of these steps, which is actually building the modeling, and then actually deploying these models, because I think these are 2 very, very critical steps that oftentimes consume a lot of time. Now, for your project, I don't know if you guys are specifically going to be thinking about these 2 pieces. When we first started Tartil, it actually also started at a Muslim hackathon. I don't know if you know this, Shams, but 2 years ago when we started Tartil, it was also at a Muslim hackathon. And at that point, the only thing that we did was really the first 2 steps: define the objective and start to collect data. but it was, it was still the launching point for Tertil. Those aren't the 2 points that I'm going to be talking about, but if you guys have questions, obviously feel free to ask me about any of this. My focus is going to be doing modeling fast and deployment fast. Does that make sense? Any questions? Any intermediate questions or anything like that? Okay, if not, let's just jump into it. At any point, just feel free to come in with any sort of questions. Okay, so let's talk about developing machine learning fast. Okay, so there's a couple of things. Oops, I think some of these. Oh, when it comes to developing machine learning fast, yeah, this slide got skipped. So there's the way you should think about this is machine learning always takes a lot longer than you think it will. I think unlike maybe traditional software engineering where you can scope out time pretty well, you can say, okay, this feature will take this long. With machine learning, it's very, very hard to know ahead of time how long something will take, because you really don't know, for example, how much data you'll need to train a sufficiently accurate model. And so instead, what you should start to think is, you start to think about this as developing as lean. You should think about lean development. In other words, how can I develop a machine learning model as simple as possible that allows me to prove what I want to prove or demo what I want to demo in this hackathon? So let me give you a few examples. So one example is a lot of companies nowadays, they're AI companies, they call themselves AI companies, but they're actually AI false doors. In other words, they don't really have AI behind the scenes. They actually have a human person who's acting as the AI. There's a lot of, like, for example, if you can go find this online, there's a lot of like AI powered lawyers. You start using them and you're chatting with them and you think that it's an AI that's doing everything, but it's actually a real lawyer behind the scenes. So why would a company do this? Why would they pretend to be an AI company when they're not? Besides the hype, the other aspect is it allows you to prove that people actually care about using an AI-powered lawyer. And then you can kind of develop the AI later on. Does that make sense? So if you're trying to prove a business case, you might want to think about doing something like an AI false door. However, I imagine most of the people here, they don't find this very satisfying because, well, at least I think most of the people here are techie folks like myself. We want to build the AI systems. We don't want to, just pretend that we have AI behind the scenes. But still, you should think about speeding up development. So what else can you do? Try to think about what is the minimum intelligent example that you can use to convey that your system actually works. Okay. So I'll give an example of this in just a second, but the main idea is it's very easy to think, okay, I'm going to build this AI system to do everything. It's going to listen to people's recitation of the Quran, for example, in the case of Tertil, and it's going to understand every character that they do. And if they make a tajweed mistake, it's going to catch it. We had all of these, very, very ambitious things that we wanted to do and we still want to do. But for the purposes of a hackathon, you want to obviously think about what is the minimum thing that I can do to actually demonstrate, some excitement factor and some utility for my users. And so that's, I'll come back to what we decided to do with Tertil. One last point that I'll mention is pre-processing and post-processing. There oftentimes, a lot of what you want to do with machine learning, you might be able to simplify your task a lot if you do some pre-processing and post-processing on the data. And maybe at this point, I'll give the example of Tertil to kind of connect all of this together. So for Tertil, as I mentioned, our goal was, okay, we want to be able to understand what a user is saying when they're reciting the Quran and to be able to correct them. We realized very quickly that it's very hard to do this in one hackathon, right? That's not going to work. So a couple hours in, we're like, the hackathon's going on. And we're like, okay, we only have, 24 hours left. What do we do at this point? Well, we stepped back and we were like, okay, well, what is something that would still be pretty cool to be able to show in this hackathon? And what we decided was, kind of the basic MVP or the basic minimum, intelligent example that we could use was something that could at least listen to what you were reciting and could actually tell you what ayah it was, okay? It couldn't maybe understand every single word. Maybe some words would be wrong, but at least you'd be able to tell the gist of what ayah you're trying to recite. That was itself, it still could be a challenging problem, but one of the things that we did was do this pre-processing and post-processing that I talked about. And what we ended up doing was we ended up restricting our search space to words that are in the Quran. So we did a bit of pre-processing there. And in terms of the post-processing, we would only show results once we had some accurate confidence that we knew what you were reciting. So we let the user recite and recite and recite. Once we were confident, then we would show them the ayah. So things like that can simplify the machine learning piece. It can offload some of that machine learning effort to some of the other pieces of your software product. Does that make sense? Let me pause here if there's any questions about this first piece of developing machine learning fast. Yeah, there's something here. Okay, it looks like there's a question.
Oh no, that's Anik saying yes.
Okay, so in that, Anik has a question?
No, oh, he says, could you explain pre-processing and post-processing a little more?
Yeah, absolutely, absolutely. Right, so the core idea is that typically we might fall into this way of thinking that we want our machine learning models to operate on the raw data and give us the full predictions, right? But in reality, oftentimes that can be a little bit challenging. So with the speech example with Tertil is just one example. Another example you might think is, let's say you're building an application to, I don't know, to look at a scene, take a picture from your phone, and it recognizes words and it says those words aloud for people who are visually impaired, right? So rather than so they can just open up their phone and look at the screen, and if there's a sign anywhere, their phone will tell them what that sign says. Okay, so naively you might say, okay, well, I want this. Oh, there's another question. Okay, that's somebody else. Okay. So naively, you might actually imagine, okay, I need to train this from scratch. I need to build this machine learning system that can handle all of these different use cases. But for example, you might be able to find certain pre-processing you might be able to find certain libraries that can tell you where text is on the page, right? So you might take your image, you might pre-process it through one of these libraries, and then only have to deal with that snippet of text and only focus on going from that text to doing maybe the OCR on that text and then saying it out loud. Like, in other words, you've taken the problem from a very difficult problem, which you might think, like, I have to find all of the text on this page myself, then build models to do all of that. You want to try to simplify the problem as much as possible using existing tools or existing pre-processing. Another actually decent example is with this voice. Someone asked about voice recognition. Do we develop it yourself or do you use existing programs? That's actually a good example as well. As when you're trying to build this minimum intelligent example, don't try to necessarily build everything from scratch. If there's something that you can use, for example, there is Google Speeches API, and we used an adapted version of that actually in our first prototype to answer this question. Use that so that at least you can get your product out there, right? You can get their product in the hands of users, which will help you collect more data and validate that people actually care about the product that you're building. Does that make sense? Cool. All right. Let's go on. So I'm going to talk about one other thing that you can do to develop machine learning fast. And this is a slightly technical piece. This is why I mentioned in the description that it would help to have some machine learning familiarity. I'm not going to show any code at this point, but I'll just talk about this concept of transfer learning, which is so incredibly powerful. If you guys have taken a machine learning class, you guys have probably encountered transfer learning. If you haven't, definitely look into it. Because it changes the game completely when it comes to actually building feasible machine learning models with limited data. So the core problem is nowadays when you train machine learning models from scratch, it typically takes a lot of data. And it takes a lot of time to actually train neural networks on data. But there is this alternative paradigm of transfer learning which saves you time and data. And I'll just give it an example. Suppose you're training a machine learning classifier that's designed to classify cats versus dogs, okay? And this could be anything, and this is just an example I found online. Maybe you could be classifying different hijab brands or something like that, really anything that you want to build a machine learning application around. So let's say you decide to train this from scratch. Okay, so you might think that this isn't that hard. I mean, come on, there's only two classes, a dog versus a cat. And they're pretty distinct to the human eye, so it should be pretty easy for machine learning systems to also classify it. It turns out that it's actually very hard. So even when you collect 25,000 images of cats and dogs and you build a classifier, you only get something like about, so what I have here is, you can focus on the bottom graph here, is what I've plotted is I've plotted classification accuracy. And the orange line is the one that matters because it's the classification accuracy on my test data. And you can see here that it gets about 0.7%, 70% accuracy. Now you might say, well, 70%, that's not bad, it's not terrible. And in some use cases, you might be right. But you have to remember that even if the machine learning model was just guessing randomly, it would get 50% accuracy, right? Because there's only cats or dogs. So all of this data that we gave the machine learning model, it only got us from about 0.5 or 50% to about 70% accuracy. And that was with 25,000 examples. If you're building this hijab classifier, how are you going to get 25,000 pictures of hijab and label them, with different brands or whatever you want to do? So instead, what you can do is you can actually train from a pre-trained model. So what do I mean by this? So the idea is that there are lots and lots of machine learning models that people have already built. And they have released those models for people like you and me to actually use. And you can go ahead and actually take one of these models, and rather than training from scratch, start training from one of these models. Okay, so these models were maybe designed to classify a lot of different images. So ImageNet is like a data set of 1,000 different categories. And these models are designed to classify all of these different things. So they have a lot of knowledge already built into them. And so what you can do is you can take that model now and you can say instead, hey, I'm going to then just take this and just focus on the use case of cats versus dogs. Okay. There's lots of great tutorials on how to do this. I won't get into the technical details, but I'll just show the results of what happens when you actually end up doing something like that. What ends up happening is, again, focus on the orange curve on the bottom, is you get an accuracy of more than 97%. Okay. And this is with the same number of images of cats and dogs. You only have 25,000 images, but you can get significantly better results. Okay, and not just you can get significantly better results. I'm comparing the two plots that I just showed you on this is the original model where I'm training from scratch, and this is the bottom one, is training a pre-trained classifier. And what you can see is not only do you get better final results, but you also get them much faster. Okay. What I have on the x-axis here is the number of epochs, which, as you may know, is the number of times I go through the whole training data. So the number of times my machine learning model analyzes my full data set. It's just like a measure of how long you've been training. And you can see here, it takes about 17 epochs to get to the 70% accuracy. Here, within one epoch, I'm already at 97% accuracy. It's just so much better to take a pre-trained classifier. One other thing that, if you're familiar with this data, this ImageNet model, you might say, well, okay, ImageNet already has some images that look like cats and dogs. So maybe I'm relying on this knowledge that this data set already contains. But this data set wouldn't contain images of hijabs, for example. So does it still work in the context that I gave you, in the example that I gave you, or in more difficult examples? And to that, I can point to some of my own research at Stanford. We actually classify pathology images, which are very different from, like images in the data set like this. But still, even so, we found that pre-trained neural networks give us much better results than training from scratch. Okay, so that's the second piece. When it comes to modeling and deploying fast, think about pre-training as a way to speed up your process and get much, much better results, even if you're doing something very different from what the original model was trained on. Okay, so I know that was probably a little bit fast, but if anyone has any questions about that second step, I'm happy to answer them. All right. So And now at this point, I'm going to actually talk about the other piece here, deployment. Okay. So now that, let's say you have a machine learning model and you're happy with its performance, and you want to build a product around it. Okay. Or you want to demo it. Or you maybe even want to debug it. But the point is, you want to use your machine learning model in some capacity, whether it's for some sort of internal kind of debugging or external. You want to show it to the judges at the hackathon, for example. So a lot of people spend a lot of time building a UI around their machine learning model. And it's just so much work. They build a Flask app for their model. They build a front end in React oftentimes, and then they finagle Heroku to try to get it set up so that they have a link that they can use and actually share it with other people. In my own experience, I've spent hackathons where I've spent like maybe 6 hours working on the machine learning side and like 24 hours getting it all set up and actually accessible and showable and demoable to a presentable level. And I feel like personally that shouldn't be the case, right? The machine learning model work is oftentimes the more exciting work. It's the more novel work, but we end up spending most of our time just getting the front end and making it look nicer. So here's where I want to show you something that I've actually built myself. And what allows you to actually deploy and debug your model in 3 lines of code. And it's in 3 lines of Python code, which if you're already doing machine learning, you're already writing your code in Python. So you don't have to learn front end or anything like that in order to get this to work. So for that, that library that we built is actually called Gradio. And it's super easy to get started. And what I'm going to spend maybe the next 15, 20 minutes is just showing you about how it works. And hopefully what I'm hoping is as you guys build your machine learning models, you can actually find it useful to deploy and debug this. But let me give you a sneak preview right now. This is kind of like the quick start. If you just want to get started with Gradio, here's how you do it. The first step is to install Gradio, which you install just like any other sort of Python library. The second step is to create a function that you care about, okay? So let me just give you a very simple function here. This function takes in a name, and then it just it puts the word hello before the name, okay? The final thing that you have to do is you have to decide what kind of UI components you want. In this case, what I'm going to say is I want my UI components to be an input text box and an output text box. Then I click launch. And when I do that, my browser window will open up and I will actually see the following UI that's been automatically created for my function. And as you can imagine, what's going to happen is I can actually start using this function immediately. And I can actually type in a name here and it's going to start actually working with my Python code. To make this a little bit more real, what I want to do now is I want to actually go ahead and show you a demonstration of Gradio. So I'm going to go ahead and pull that up. But as I'm pulling that up, does anyone have any questions?
Is Gradio accessible to anyone, for anyone to use for free?
Absolutely, yeah. It's a completely open source public library that you can use right now and install and start using it. Okay, and let me show you how it's actually done. So, okay, so here, this is a Jupyter notebook. I'm going to start off with some just kind of basic examples, and then I'll show you some more realistic machine learning examples, okay? So as I was mentioning before, at its core, so Gradio allows you to wrap UI elements around Python functions. And there's a lot of different UI elements, which I'll show in just a second. So let's start using it. I think the easiest way sometimes to get familiar with the code, with a library or with code base is just examples. So I'm gonna go ahead and import Gradio, and I have this function that I've defined here. All it does is it replaces the word hello, replaces the word world with Google, okay? And what I'm gonna do is just like I did before, I'm gonna pass in the function of this, which is replace hello with world. The input is gonna be a text box, the output is gonna be a text box, and then I'm gonna go ahead and launch this interface. So let's see what that looks like. So as you can see here, it opens it up and it starts running. This input here is a text box here. The output is an output. Let's try something. Let's try hello world. Okay. And you can see here, it connected to my backend function, and it replaced the string, and now I can see that as the output. And you can see also how long it took to run, which in this case was less than 10 milliseconds. But point is here, you can do a lot of things. You can modify the function here. You can do this, and you can say, okay, let me run this. And the cool thing here, by the way, is that it also runs directly within your Jupyter notebooks. So you can actually use this as a way to try out your model immediately if you use Jupyter notebooks. Let me run this. Oh wait, why is it not working? It should replace it with Salam. Oh, you can use it to debug things. Okay, this is not case sensitive, so I'm gonna have to fix that later. Let's just test it now with the case sensitivity. With the uppercase, if I do this, it should say Salam world, and it does. Okay, so this is just a very easy way to start interacting with your Python functions or with your models. Let's try a more interesting example. So what I'm going to show here is the MNIST model. So for those of you guys who are familiar with MNIST, MNIST is a data set of handwritten digits. And what I've done is I've trained a model to actually recognize the different digits in this data set. Okay. And what I'm going to do here is I'm going to go ahead and create an interface around this model. And it's going to be very simple. I'm sorry, I'm going to edit this code here a little bit. But with the input interface now is going to be a sketch pad, okay? So it's a different interface you guys that I went before. We had a text box. Now it's going to be a sketch pad. Why am I using a sketch pad? You'll see in just a second. The output here is going to be label, and I'm going to have it display the top 4 classes, okay? So let me run this. You can see here on the left, I have the sketch pad that's been created for me. And I can use this to, for example, draw things here. And I can look at what the output looks like. It recognized that this was a 2. Let me try this. Oh, it figured out it was a 3. Okay, let me do this here. See what it says. It's a 4. Interesting. It's pretty confident about that too. So you can see here that this is this basically is a very simple way to now start interacting with my models. And maybe I can actually use this to identify issues with my model. Okay, so let me show you an example. Okay, this is a 1. That's pretty good. But what happens if I draw a 1 over here? Okay, it actually thinks it's a 0. That's really weird. You might have thought that your model was very good, but it turns out it can only handle things that are centered on the screen. And so this, it'll probably be fine. Oh, maybe not. But you can start figuring out the failure points of your model by by doing like this kind of interactive inference with your machine learning model. I'll show one more example, and then if anyone has any questions, I'm happy to take that as well. I'm going to change just one thing, okay? I'm not going to change anything except I'm going to add the live equals true as a parameter to the interface object. And when I have live equals true, what this allows me to do is it allows me to start drawing, and then the machine learning model actually makes predictions as I'm drawing, okay? So let me try this again. Let's try a 3. Okay, let's see at what point a 3 becomes an 8. Okay, so you can see now it thinks it's an 8. Okay, it's transition, and I complete it. Just an example. Again, just another cool way to start exploring your model. Okay, I have a few more examples that I want to show, time permitting. But before that, does anyone have any questions? Yeah, great question. Can we deploy this UI on a server, or is it just local? I was going to talk about that, but let me actually talk about that in just a second. Okay. So I'm going to show you this cool example here. So this is I talked about ImageNet. This is a model that's been trained on ImageNet. So it's basically designed to classify. Will this work? Let's see. Okay, hopefully this will work. Let's try it. Okay, so this is an image. This is something that classifies different images. And I'm going to show it to you just now. So this is so the interface here. Sorry, let me show you one more thing before I do that. The interface here is an image interface. So an image interface is different from a sketch pad. It allows you to actually drop your own images directly into the model. And you can see what the model's predictions look like. Oops, this is not a shower curtain. What happened here? Okay. Oh, I think I know the issue. Let me see if I can just debug this. Debugging live usually does not work, but I'm gonna just try it. Oh, you know what? I think I know what it is. I have the let me just copy this code here because this should work. Okay. So what I'm gonna do is rerun this. So what I'm doing here now is, oh, there seems to be a question. Okay. So yeah, so I'm rerunning this. The issue was actually that, let's see if this actually works before I say that I've solved the issue. Yeah, okay, cool. The issue was that I didn't pre-process the images correctly. But now it actually works. And so I can test this. I can put other images here as well. Let me just clear this here. I can put in a different image of, for example, put another image of this cat here. Oh, look at this. This is a cute tiger cat. You can also, for example, probe the behavior of this model to images that are not in its distribution. So for example, this classifier wasn't actually trained on images of celebrities or photos of portraits or anything like that. So what's going to happen when I put this in? Well, the classifier is going to try to make the closest association that it can, right? So it's not gonna know that this is Iron Man or what's his name, Robert Downey Jr. But it's going to try to match it to the closest label that it does have. And so in this case, it actually maybe recognized him from a comic book or something, or I don't know, or this pose is very comic book-like. But you can see here, this is a failure point of the model, or a failure point of that you may want to do something about if you expect that your users might be putting in inputs like this. Now, let me actually show, so somebody asks, is this just local, or can we actually host this somewhere on a server? The cool thing about Gradio, probably my favorite feature, is that you can actually just set share equals true, okay? When I set share equals true in launch, and let me rerun it. So what ends up happening is that the same code gets run again, and what's happening is that it's running all of the code again. I probably shouldn't have done that. I should have just run this last line, but khalas, that's fine, inshallah. But what ends up happening is it continues to run the interface locally, but it also creates an external public link. And this is what's so useful if you're, for example, at a hackathon and you want to share it with your collaborator that's working on the project with you, or you want to share it with the judges or the people in the audience, right? You can actually share this public link, and I'm actually going to share this with you guys right now. I'm going to share this with you guys. So you guys can actually literally open this up on your computer, and you can actually try it. You can try what this interface looks like. You can put in your own pictures, and you can, get some cool predictions. Now, the really powerful thing here is that the model continues to run on my laptop. So you don't have to worry about any sort of dependency issues. You don't have to worry about packaging it up. You don't have to worry about uploading the model on any sort of server. The model is running in the same environment that it was just running 5 minutes ago. But now the brilliant thing is that someone can access it from their own browser, put in their images, the model runs on locally, and then Gradio sends the predictions back to the server, and then you can get the model's results. Hopefully. Okay. Did anyone try it by any chance? Does it work for them? I'm noticing the small error. So I'm wondering if that's page doesn't seem to load. Okay. Hold on 1 second. Live demos, man. Oh, it just loaded? Oh, interesting. Weird. I just reran it, so I wonder if it's gonna go away now. Okay, maybe it just took a second, but now it's loading. Maybe refresh it on my side. Okay, cool. So it seems to be working for at least for an e-care. Okay. All right. So yeah, absolutely. You can try this with your own model. The way that we've set it up, someone asked, is this available to use publicly? Yes, and it's completely free. One limitation though is that these links, they expire after 24 hours. So this isn't like a permanent hosting solution. We have some recommendations if you want to use Gradio for permanent hosting on how to do that. And I'm happy, just contact me afterwards, and I'm happy to tell you about that. But in the meantime, you can use this to at least to demo something for 24 hours. Okay, awesome. I'll just end with a couple more examples of some cool things that you can do. You can actually, some people are posting their predictions and their misclassifications as well. Okay, so the last thing here is, okay, there's a question here. What is your favorite machine learning resource for beginners? Great question. It depends really what you mean by how much of a beginner you are. If you've never really done any sort of machine learning before, the classic kind of gateway into machine learning that people use is, there's a famous course on Coursera by Andrew Ng that covers the basics of machine learning. If you've never done any machine learning before, that's probably a good place to start. There's also a series of really good lectures at Stanford about deep learning in particular. I highly recommend them. I think they're much better than Andrew Ng's lectures as well. Maybe I can send out a link afterwards to Shams, and then you can circulate it. Shams, how does that sound?
That works. Isn't that Coursera's CEO? Andrew?
Yeah, I think so. Yeah, he is also.
Gotcha.
He started Coursera, and then he taught the machine learning course as well.
Gotcha.
Okay, cool. Have I ever met him? I have actually met him. I took his class at Stanford. I audited it, but there's actually this is a very tangent, but the big TA for that class is actually a good friend of mine. He's a Muslim guy. His name is Yunus. Very smart guy. Okay. Let's move on. I'll just show a couple more examples of what you can do with Gradio, and then I will kind of maybe close this up, or if anybody has any questions. One thing that you can do is you can also run models that have more than one input, right? Or more than one output too. So here's an example of a model that's a question answering model, okay? So the way that this question answering model works is you provide a paragraph that's like the context, and then you ask it a question, and then it answers it for you, okay? So I'm gonna go ahead and run this. You'll see here what I did was I have a large text box and then a short text box. I basically created two inputs. So this would be the inputs, and then I have one output, which is just a text box. If anyone has any questions on the particular syntax, I can answer that. But I think you guys might be more interested in the actual the model itself. So what I have here, let me go ahead and, oops, let's change this up a little bit. So let's run this. Okay, so I can give it an example question, and actually, you know what? Let me just run it right here. Inline equals true makes it print in your Jupyter notebook, and this is easier to interact with. So I'm going to copy this paragraph that I have here about Google. Actually, it can be anything. Why don't we write a paragraph about Ummah hacks? I'm enjoying. I'm attending. How do you spell it, Shams? Is it with an H?
You got it. Yeah, okay. Capital H. Yep.
Okay. And I'm building cool web app to classify cookies. Okay. Okay. So I've been here for 1 week. Okay. So now you can ask it questions. So you can say something like, "What am I attending?" Okay. Okay. Submit. And okay, so I'm attending a hackathon. Okay, what's the hackathon called? Yeah. Ummah hacks. Okay, let's ask it maybe a little bit more difficult thing. Let's say, how long have I been at the hackathon?
Or how long I have been at Ummah hacks?
Oh yeah, let's do that. Have I been at home? Yeah. 1 week. Okay. All right. So you can play around with this. It's definitely not perfect. You can say something like, "Oh, what am I classifying?" Let's see if this works. Goofy. Okay. Any other questions from the audience? Let me add a little bit more to it. I showed it to my brother and he was not impressed. Let's see. Did my brother like my web app? Let's see if we can answer this. Not impressed. Okay. Can this be used for more advanced things? Yeah, I mean, what do you have in mind? I've intentionally chosen a very simple example, but you can certainly try different things. Like, for example, imagine this. So like one of the things that you might be interested in building is something that takes in, I don't know, maybe Islamic text and searches it and answers questions from it or something. You know, like a mufti like lookup or something like that. I don't know, searches fatwas and it extracts the right thing. And you can see like it can take pretty complicated technical text like this over here. And I can say something like, you know, I can ask it questions. I can ask it like, when did, you know, when did the founding of Google takes place? I can ask it this. You can see it actually 1998. I think that's correct. Yeah, September 1998. But you can do all sorts of different things. The question is, what have you been using this for? Like examples. I have personally, I've mostly been, you know, what we do at Gradio is not use specific models. We make these models more accessible and usable by developers. So we build developer tools. But I know in general, these models are used for all sorts of things. So for example, one thing is doctors will type clinical notes, and then they'll sometimes have to search these clinical notes to go back on their history and see, okay, well, when did this patient take this drug? Was he allergic to this or not? And models like this are being used to make it faster for doctors to do this kind of lookup. Yeah. Any other questions? Okay, let me move on. The final thing that I'll show is something that it might be interesting to you guys if you guys are considering different models. So let's say you've either trained a few different models yourself and you're trying to see which one's the best, or maybe you found a bunch of models online and you want to know which one's the best. So what I have here is I have two models, and what I'm going to do is I'm going to go ahead and actually, for this to work, I need to turn off my video because I'm going to be letting this web app actually. Will this work? Cannot access webcam. Okay, let's try to open it up on a separate thing here. Allow. Okay. So what this model does, oh, error. Oh, okay, not sure if this one will work, but I can do something else instead. So I should run this somewhere. Okay, so by the way, you can find a lot more examples of how to use Gradio on our website, gradio.app. And you can find also a lot more examples on the GitHub page as well. So if you go onto our GitHub page or on our app, which you can find, yeah, gradio.app, you can find it and you can try out a lot of examples. So I'm going to show one example that from our web page. Let me just run all here. So what this model is going to do is it's going to actually compare two different image classification models. And you've seen one of these models already, but I'm going to show you now two of them side by side. And again, it's very easy to get this working with Gradio. You just pass in two functions instead of one function. And then what will happen is it'll create an interface that actually allows you to, start testing and comparing them both. So let's give it an example here. Okay, so right now it's downloading the models. It should run. Okay, so a public link is created. So again, you guys can actually go on this link. Let me send this to you too, if anyone wants to try it. And what you can do, once this loads, okay, cool. So what you can do here is you can click on an image and you can, or let's put on like, I don't know, one of these, let's put bike image. And you can see it's loaded here. I'm going to submit it. Now it's going to go through both of the models that I put in. There are two different image classification models, and I can see which one is actually better. Oh, well, oh, interesting. But in this case, both of them got it wrong. Both of them said tricycle. But this one at least was more, it thought it could be a bicycle as well with more probability. So maybe I want to use this model instead. But on the other hand, the latency of this one is a little bit lower. It takes 1.18 seconds. This one is a little bit faster, 0.89 seconds. So maybe that affects what I want to do with this model. You can also try, like if you try out of distribution images, you get even more interesting results. So like I'll put this in here. Okay, so one model said hairspray. that's what it saw when it saw this picture of Robert Downey Jr. The other model saw a jersey. So you can decide which one is the less egregious mistake. And maybe that'll tell you something about this. Cool. Okay, so that's, I think I'll pretty much end there. To summarize, I hope, inshallah, that this talk has given you a few tips about how to develop machine learning models faster by, again, focusing on what is that minimum intelligent example that you can use to demonstrate that your product is interesting and works and is usable by people. Sometimes it's best to go for the low-hanging fruit. The other thing is, if you are building a machine learning model, do try to actually use transfer learning if you can. It's really a game changer. For everything that I've done for Tertio, we're also using transfer learning. It just gives you a leg up. And then finally, I hope that Gradio is something that can be useful for you guys as you guys are playing around with different machine learning models. You can easily create GUIs from machine learning models, and you can share them with other people with using these public links like I showed you for 24 hours. Yeah, so, and if you want to learn more, you can find information at gradio.app. Let me also give you guys my Twitter. That's probably the best way to reach me if you guys are interested. Okay, it's called Abid Labs. So you can find me on Twitter here. Twitter. And besides that, so I know that Shams, I'm going to send you those resources that somebody asked about. Are there any other questions besides that?
I have a more of like a career question.
Sure.
Somebody who has like a background in software engineering, how can they transition into machine learning and data science and into something more closer to this?
Yeah, good question. So there's this, and then there's also another question which I'll get to in the chat. But from a career perspective, that's a good point. So like one of the great things about machine learning is that there are just so many resources out there trying to, that you can use to get started with machine learning. If you have a general software background, that's pretty much, that gives you a leg up. Going from that to machine learning isn't honestly that, what I'm trying to say is that so much of machine learning has been abstracted away to the point that software engineers can easily start using it. So if you know, for example, the Keras framework in TensorFlow, it just makes training machine learning models so easy. Similarly, PyTorch is just like such a convenient library for training machine learning models that really, like, you don't have to worry about the math really behind machine learning model. There's some knowledge you should pick up, and there's a bunch of great lectures online that you can use to pick that up, courses on Coursera and that kind of thing. From a more practical point of view, though, let's say you have a software engineering job right now. How do you go from that to machine learning? Right now, unfortunately, I think I would say that in a lot of places, if you actually want to do the most interesting machine learning work, you do kind of need to have a master's in machine learning. It's not like you need to, but a lot of places they put those qualifications out there. So what does that mean? What that means is often, I know a lot of friends, for example, who've joined machine learning teams. They've applied to machine learning teams as software engineers, and they get involved with some of the other like infrastructure work. But using that, then they get exposed to lots of great machine learning teams, and then over time they transition into the actual machine learning work. So if you don't feel like doing a master's or something like that, which I really feel like you shouldn't have to, but a lot of places do ask for the kind of graduate degrees in machine learning as requirements. try to see if you can find a team that does machine learning work and get involved in any effort that you can, even if it's not the core like machine learning training models. It could be some of the more ancillary work that's still important and still very useful. And then over time, it might allow you to actually join doing the core machine learning effort. There's a technical question here about, can you configure different routes on Gradio for different endpoints? Not at the moment. At the moment, it's just one route that's used for prediction. Yeah. But Gradio is an open source library. I will mention that. I think I mentioned that before, but what that means is you can create issues and people have, and you can create pull requests and people have, and start contributing code to that. And I'd be super thrilled to see you guys contributing, or even just going to the library and creating issues, limitations, because all of that actually helps us a lot. It helps us as an open source product because that allows us to get more exposure, like the more issues and even the more stars. If you guys can star the repo, that would mean a lot as well. The more stars, the more issues, the more activity your repo has, the more GitHub showcases it and the more seriously it's taken by people. So yeah, so to whoever asked that question, you're welcome to go ahead and create that feature. Or
you
request.
Put the link for that in the chat? The link to the GitHub?
Yes, of course. Yeah, thanks for that suggestion. Let me go ahead and put it here. All right. Any other questions? We have just a few minutes left. But any other questions?
You had mentioned that right now, when it comes to getting jobs in machine learning, there's a very high degree of precedence given to those who have masters and graduate like certifications. Which programs in particular are like heavy or weighed the heaviest right now, or are given the most like credibility?
Yeah, you mean what do you mean specifically? Like, are you talking about master's versus PhD, or what do you, or like the degree itself?
In general, yeah, the degrees and the schools that offer them.
Yeah, well, nowadays, I think increasingly, you'll find that almost every major university will have some sort of program in data science or machine learning or AI. And if not that, then at least they'll have something in computer science. But then you can have tracks within computer science for AI, and that means a lot. If you can graduate with if you can graduate with a degree like that, of course. It also does depend on what you're trying to do. If you're trying to do machine learning research, like the real cutting edge stuff, then you almost need to have a PhD, or you definitely need to have at least a master's with a thesis component. But if you're more interested in the machine learning engineering aspect of things, building these systems, training these models, using existing architectures, then you don't need that as much. Yeah.
Got it.
Okay. Great question about privacy. Okay. Yeah, this is actually a fantastic question. So when it comes to training machine learning models, you don't really have to worry about copyright as long as you don't distribute the data itself used to train the model. So like, for example, if you take the question of ImageNet, they literally, I think, scraped 3 million images off of Google and used that to build their data set. Okay. And those images are copyrighted. Many of them are copyrighted. So they don't release the data, but they will release models trained on that data. So you can do something similar. Anything else?
I think somebody is about to hop on, or he wants to, he was watching this on Facebook and he wants to ask a question. So he's going to hop onto Zoom really quickly.
Oh, okay. That's cool, mashallah.
Shams, I actually did not have a question. I was just hoping to hop on the Zoom call.
Oh, hey. Well, welcome. I'm glad you're here. Alhamdulillah. Okay. It's kind of awkward to kind of close right as soon as you join the, the Zoom call. But okay. A future idea: you should make tools for data scraping. Gets super annoying. Yeah. No, I feel you completely. Actually, one of the interfaces that we're planning on building, and this might be interesting for you, is just like we have. Do I have an example pulled up here? Yeah. So just like we have this image interface here, which allows you to upload your own models. Upload your own images, right? It also shower curtain. Come on, not shower curtain. Okay. Oh, this is back to. Oh, maybe it's this one. Oh yeah, I think it was this one. Yeah. So just like this interface allows you to put up your own images from your desktop or anything like that and get predictions. We're making one, inshallah, that's going to be called like image search, and you can put a search term and it scrapes some images off the web and you can immediately start putting it in. So rather than having to go online and download an image of a mosque or something, someone tried it here in the group. I don't know if you had to download that image or whatnot, but you can just search mosque. It'll pull up a few images and you can see if the predictions match what you expect it to be. And the other powerful thing there is a lot of these models you'll find, by the way, are biased in very interesting ways. This is a big area of conversation right now in machine learning. Is these models will work really good for people who might have Caucasian skin, right, or might be Caucasian, and it realizes that it works really well. There's a lot of data there. But somebody whose skin tone is, unless somebody who's African American or something, you put their pictures in, and these models don't behave like how they should. That's because the data that they were trained on is biased. So one of the things that you can do with these interfaces is start exposing these biases, learning about these by exposing them, and then hopefully fixing these things as well. Okay, it's 8:29, Sham. So should we wrap it up?
Yeah, I think that that should be. There is one more. Or did you answer Samih's question?
Oh, maybe I missed it actually. Where?
So it's the last one.
Oh yeah. Okay. You mentioned that you were doing machine learning work with healthcare. Okay. Yeah, absolutely. So my area of research is really the intersection of machine learning and healthcare. So I've worked on a lot of different applications there. The most recent one is actually working on pathology images. So pathology images, you guys might have seen some of these. They look like these, right? And these are images of like cells and tissue. So what we're looking at is seeing if, so right now it takes a human pathologist a lot of effort to look under a microscope and identify different proteins and different issues with different cells that are kind of gone wrong. And that's used to identify disease, it's used to identify what kind of cancer someone might have. So we're looking at ways to actually have this done using machine learning. The challenge is so many of these features are tiny and it's very easy for a pathologist to miss them. And so what we can do is we can come in and actually say, hey, you should look over here. It looks like there's something wrong here. And that way we can make sure that pathologists don't miss the things that they shouldn't be missing. Yeah. General thoughts on GPT-3. It's really impressive. If you guys haven't looked into GPT-3, you should look into it. I think it's a game changer. I think if I was you guys, I would drop what I'm working on and find some way to use GPT-3. Everyone should start a company around GPT-3. No, but in more seriousness, I think it's for those of you who don't know, it's just an incredibly powerful text completer. You give it the start of some text and it generates very, very coherent sounding like it was written by a human completion for that text. So you can start writing an essay, you write the first 2 sentences and it completely writes the rest of your essay for you. And you're just like, wow, it's so coherent, it's so topical. You start a poem, it finishes the rest of the poem, keeping the rhyming scheme even, and keeping the topic of the poem. I think it's gonna be so interesting and it's gonna create a lot of questions about, I think especially in the creative side of things, the content that you can create sounds so human-like, but it's not, what does that mean? I think poetry is going to be very, very interesting. There's going to be interesting conversations within the poetry space about this and other things like that. I think it's going to make creative arts very interesting and it's going to be very assistive there. That being said, it does make a lot of logical mistakes. So I don't know how much of a game changer it is going to be in general. I don't think you can build a business just around like answering questions with GPT-3, for example, because it makes a lot of mistakes. But again, going on to more things that are more loose, like poetry, you might have some interesting impacts there. I don't know. Those are just my initial thoughts. But I'm just like everybody else, very excited to see what happens with GPT-3. Yes, if you want to contact me, just find me on Twitter, inshallah. My DMs are open.
MashaAllah.
All right. Good stuff, inshallah. I think we should wrap up. Jazakallah khair, everybody, for attending. The Twitter, I'll just send it out here. Yeah, Jazakallah khair, everybody, for attending, and especially Shams and to the committee that organized this. Thank you so much for having me.
Thank you so much for coming. Jazakallah khairan. We hope to learn more about what Gradio has to do soon, inshallah. Jazakallah khairan, everybody. And we will be signing out. Assalamu alaikum.
Assalamu alaikum.